Okay, here's 2.7. We're going to look at combinations of functions, and then we'll take a moment and look at composite functions. Okay, so combination functions, it's actually fairly simple and straightforward. So these are the four different type that we are going, that we'll work with. So we have the sum, the difference, the product, and the quotient. And so really the biggest part about this is making sure you just know that what the notation represents. So right here you've got f plus g of x. You're not multiplying, it's saying it's function notation. So take the f function plus the g function, add them together. And so that's what that's equivalent to right here. So just take the f function, take the g function, combine like terms basically. Same thing with the difference. The only thing is you'll have to be a little careful because the subtraction will need to get distributed if there's multiple terms um, of the function that is being subtracted. For the product, you're going to multiply the two functions together. You might have to FOIL or do something similar to that if you're multiplying polynomials together. Um, so we'll look at a couple examples of that. And the last one is the quotient. For what we're dealing with here, ours are going to be pretty simple. You're just going to write the quotient, and that's going to be it. As if you move on to pre-cal and further on, sometimes you'll be able to simplify these, but for the purposes of our course, we won't have to deal with that issue. Okay, so let's go ahead and look at our first one right here. So it's going to say let f of x equal negative 2x plus 3, and g of x is going to be x minus 4. Find each of the following, uh, and we're going to list the domain. Okay, so this first one, they actually give us numbers, and what the point that we're going to try to make on this first part is that 1 and 3 are the same thing. So we're not going to do this on every single example, but on this first one, I'm just going to try to show you that when you do the sum f of 3 plus g of 3, that's the same thing as if I were to add the two functions together first, combining like terms, which we'll see over here on number 2. And so, and then substituting the 3 in. So we're going to see that for number 1 and 3, we'll actually get the same result. And it's just trying to prove to you that uh, that this does hold right here on number 1. And it holds for all of them. And we could do them all like that, but we'll just do this first set right here. So let's see, f of 3. So f of 3, so I'm going to take it and plug it into the f function. So I'm going to get negative 2 times 3 plus 3. And then for g of 3 right here, we're going to plug that in right here. And so let's see, I have a plus between them. So let me see, I'm going to try to color code this, make sure we understand where everything's coming from. So then we're going to have a 3 minus 4. So I put the plus in black right there. Just that's from the plus sign from the original problem. So let's see, negative 2 times 3, let's see, negative 6 plus 3, that's going to be a negative 3. And then we're going to add that with g of 3, which is negative 1. So when you add that all together, it should come out to a negative 4. Okay, now mostly what we're going to deal with is instead of plugging in values, we're going to just leave x as our value. And so that's what we're going to see on number 2 here. Okay, so what we're going to do here is you have to know the notation that this is asking us to take the f function, add it to the g function, but this time instead of substituting 3 in, we're just going to leave the x's there. And once again, I'll try to color code this a little bit. So f of x is negative 2x plus 3, and then g of x is x minus 4. And so what we're going to do here is we're just going to combine like terms, and that's really it. It's not super challenging. So let's see, you have a minus 2x and you have a plus x right there. So it'll give us a negative x. And then let's see, we have a plus 3 and a minus 4. That'll give us a minus 1, and that's our answer. And that's how most of our answers will actually be, is that we're gonna end up with a new function. a combination of functions, sometimes addition, subtraction, multiplication, division. So on number 3, what we want to do here is we're just going to show that I'll get the same answer now. So what I'm doing here is, so see, I know what f plus g of x is. That's what this is. That's what this is. So now what I'm going to do is, with function notation, now it's telling me to plug in 3. So now what I'm going to do is I'm going to plug in a 3 right there where I have x. So I'm going to have negative, and I plug in a 3 right there, and then I have minus 1. So I'm just taking that. That's what f plus g of x is. Now I'm turning it into f plus g of 3. So the only difference is the x is now a 3. So now I have a negative 3 minus 1, which is negative 4. So you can see you get the same result. So really this first part was just showing you that this is balanced right here. F plus g of x is the same thing as the f of x plus g of x separated, and adding the two functions together. So that's all I was trying to kind of make a point of. As we move forward, basically, all the problems are going to be like number 2. Okay, we're not going to plug in numbers anymore. We're just going to do the algebra, basically. Okay, let's take a look at number 4. So this is telling me, this notation is telling me take the g function and subtract the f function from it. Okay, so let's see, the g function is x minus 4. Now I'm subtracting the f function. Now this is where mistakes are made, so we have to be a little careful here. You need to put the f function in parentheses because you're subtracting the whole thing, not just the leading term. So I'm going to put this in parentheses, and so let's see, we're going to have negative 2x plus 3. And then I'll scroll up so I have a little bit more room. All right, so the point I was, the point that I was trying to make is that now we're going to have to distribute that minus sign to all parts of the f function, all the terms. Okay, so that's what we'll want to do next, is distribute that. So we still have our x minus 4 in front. So this will turn into a plus 2x, and then this plus 3 actually goes to a minus 3. So that's where you need to be careful. So now we'll combine our x's. So we have 1x plus 2x, that's going to be 3x. Then we have a minus 4 and a minus 3, that's going to give us minus 7. And that's it. That's what we're looking for. That's our answer. Okay, on number 5, once again, so the notation, all we're going to do here is you're going to take the f of x function and multiply it to the g of x function. Okay, so let's see, the f of x function is listed up above, but I can see here also. F of x is negative 2x plus 3, and g of x was x minus 4. I'll scroll up. Okay, so we need to go ahead. In this case, we're going to FOIL this. So let's see, we're going to take the negative 2x and multiply it by both of those terms. So let's see, that'll be negative 2x squared, and then that'll become a plus 8x. Then we're going to take the plus 3 and multiply it by both of those. So that'll become a plus 3x. That'll become minus 12. And then we have like terms in the middle, so we'll go ahead and combine those. So we end up with negative 2x squared. So that'll be plus 11x, and then minus 12. Okay, and that's it. And by the way, this isn't really a big deal, but I forgot the directions do ask for us to list the domain. The domain on all of these so far have been all real numbers. So the domain on all of these have been from negative to positive infinity, the domain on all of them so far. The only one that you really have to be concerned about is number 6, because that's where you deal with a fraction. So if you don't have a fraction, or you don't have a radical, a square root, you're not really going to have to worry about your domain. Your domain will just be all real numbers. But we'll see on number 6 that changes a little bit here. Okay, so looking on number 6, the first part's actually the easiest part, because like I said, you're just going to stack them. There's not really much you can do on these problems. As you move forward into some of your higher math, sometimes your fractions can be reduced. In our case, it's not going to happen. So on top, we'll put the g function, which is x minus 4. And then on bottom, we'll put the f function, which was negative 2x plus 3. So that's the first part. That's it. You can't cancel out the x's or the 2 and the 4. That you're not able to do that. Okay. Um, so just that's the easy part. And this next part's not super difficult, but they want to know the domain. And so what you got to remember is you can't divide by 0. So what you want to do is take the denominator. So the denominator is negative 2x plus 3. And ask yourself, what would make that equal 0? Because whatever that is, you're going to have to exclude it from your domain. So I'll start by, let's see, we'll subtract 3 from both sides. So negative 2x equals negative 3. And then we're going to divide by negative 2. So we're going to end up with x equals positive 3 over 2. Now what you want to remember is that's actually an excluded value. So I'm going to put x cannot equal 3 over 2. So those double negatives right there canceled out, and that's why I don't have those negative signs there any longer. So my domain are the values that I'm able to plug in for x. And so I can plug in whatever I want except for 2/3. And so the way we're going to write our domain, my domain would be from negative infinity to 3 over 2. But then I have to stop there. I can't include 3 over 2. And then we'll do a union from 3 over 2 on to positive infinity. So really that domain isn't much different from my other domain over here. The only difference is I'm cutting out 3 over 2. I'm cutting out one number. That's it. And so that's how we use our interval notation for that. Okay, let's try a couple more sets of these. Okay, so the directions are going to be the same. So we have our f of x and we have our g of x. Find the following and then list the domain. Okay, so let's see. Here's our f of x. Here's our g of x. So on this first one, we're just going to add the two functions together. And I'm sure some of y'all could just do it in your head. So let's see. For f of x, we're going to have x minus 5. And then for g of x, we have 3x squared. So in this case, we don't even have any like terms, but we'll want to clean this up and put it in descending order of powers. So the one with the highest power jumps to the front of the line, so 3x squared. Then we'll put that positive x next, and then we're going to put the minus 5. So we're just basically ordering it, make it look nice. Okay, so once again, the domain on this would just be negative to positive infinity. Like I said, the only ones you're really going to have to worry about is going to be like the fraction ones. Okay, so let's go ahead and look at 8. 8 should actually be pretty similar. The only difference is we're subtracting. So let's see, g of x, and this time, I guess I have g of x written first, which is fine. So let's see, g of x is 3x squared, and then I'm subtracting. When you subtract, you want to put it in parentheses to be careful, okay, because that is going to be distributed to both of those. So we end up with 3x squared minus x, and then that will turn to a plus 5, and everything looks like it's in order and everything looks good. And then once again, the domain is just going to be from negative to positive infinity. That's it. Okay, let's go ahead and look at the multiplication. So once again, we're just going to take the f function, multiply it with the g function. All right, so our f function is x minus 5, and our g function is 3x squared. So on the previous one, we FOILed. This one, you're just going to distribute because we have a binomial and a monomial. two terms and a single term. So that single term, we'll just go ahead and distribute it to both of these. So let's see, this will become 3x to the third minus 15x squared. And that is it. That's it right there. And once again, nothing crazy about the domain, just all real numbers. Okay, now our fraction one. So once again, you just put the g function over the f function. All right, so the g function is going to be 3x squared over the f function, which is x minus 5. So that's that part. Now remember that denominator cannot equal 0, so that means x cannot equal 5. If you were to plug in a 5, then the top would turn into like 75 or something, which is fine, but the bottom would turn into 0. Can't divide by 0, so that is going to be excluded. So when we write our domain, it's going to be from negative infinity to 5, but not including 5, union from 5 onto positive infinity. And there's our domain. Okay, so I got one more set of these, and then we'll look at composite functions. All right, so we're going to add the two functions to, oops, jumps around on me a little bit. Okay, we're going to add the two functions together here. So we're going to add f of x and g of x together on this first one. So we're going to take 6x squared minus x minus 1, and we're going to add x minus 1 to it. Okay, so we're just going to, we have a couple like terms. Well, this is kind of interesting. So let's see. So our x's will actually cancel out. We have a minus x and a plus x. So those will cancel out. Then we have minus 1, so we can combine those. And then we don't want to forget about the 6x squared. So this will become 6x squared minus 2, and that's it. And then once again, domain just going to be from negative to positive infinity. Okay, so subtraction will be pretty similar. This time it looks like we're putting g of x in front. So it's going to be x minus 1. And then we're going to subtract the f function. So I got to put that in parentheses. So 6x squared minus x minus 1. And so just, oops. So we'll distribute here, here, and here. So let's see, x minus 1. This becomes minus 6x squared. That becomes a plus x. And that becomes a plus 1. And so we are going to see some stuff cancel out again. So the minus 1 plus 1, that can cancel out. Then what we want to do is that negative 6x squared jumps to the front because it has the highest exponent. And then the x plus x, we can tack that on as a plus 2x. And then once again, our domain, all real numbers, all real numbers. Okay, so let's go ahead and take a look at the multiplication and the quotient. All right, so the f function is 6x squared minus x minus 1, and we got to multiply that with the g function, which is x minus 1. Okay, so this is a little different here, but it's kind of like foiling. It's the same idea. What we're going to do here is this is going to multiply by both of these. Then we'll take the middle term. That will multiply by both of these. And then we'll take the last term and do the same thing. It will multiply by the x and the minus 1. So we're going to be writing out quite a few terms here. And I'll try to color code this so we can keep track of it. Okay, so 6x squared times x, that'll become 6x to the third. 6x squared minus 1, so that'll become minus 6x squared. Okay, so that's the first term getting multiplied by both of those. Then now the middle term, which is a minus x, understood 1 in front. So when you multiply that, that'll become minus x squared. If you want to put the 1 in front, you can, but you don't have to. Then minus x times minus 1 will be turn that into a positive x, okay? And then in red, we'll multiply that negative 1 by both of these, and so that'll become a minus x and a plus 1 when you multiply negative 1 by both those terms. And then you can see we do have some like terms, so we'll go ahead and combine those. So here we'll combine that, and we'll, oh, the x's cancel out, that'll be nice. So let's see, 6x to the third goes first, and then when we combine that, that'll be minus 7x squared, and then we have that plus 1 on the back end. And then once again, our domain is from negative to positive infinity. Okay, our quotient here, so we'll put the f function on top, so we're going to have 6x squared minus x minus 1 all over x minus 1. And once again, you don't really have to worry about simplifying this. So don't try to cancel anything out. Just leave it how it is. And then you can see that you cannot let x equal 1, because if you do that, you'll divide by 0. That will cause problems. So we got to exclude 1. So in your domain here, it'll be from negative infinity to 1, but not including it. That's what our parentheses indicates. Union, not including 1, but then beyond. So beyond all the way to positive infinity. Okay, so those are our combinations functions, and so we have one more page of composite functions, and I'll make a second video for that.